Continuing with the C# tutorial, let's move down to inheritance and polymorphism. Inheritance. Inheritance allows us to define a class based on another class. This makes creating and maintaining an application easy. The class whose properties are inherited by another class is called the base class. The class which inherits the properties is called the derived class. For example, base class animal can be used to derive cat and dog classes. The derived class inherits all the features from the base class and can have its own additional features. Assume the employee class inherits the members of the person class. What is the person class called? The base class. Let's define our base class animal. Class animal. Inside of class animal we have two statements, public int legs with a get and set inside curly braces, and public int age with its own get and set in curly braces. Now we can derive class dog from it. Class dog (animal), and in curly braces we have public dog, and in the curly braces for the public dog we have legs set equal to 4. Then we have public void bark, and inside the curly braces for the bark method we have console.write the string woof. Note the syntax for a derived class. A colon and the name of the base class follow the name of the derived class. All public members of animal become public members of dog. That is why we can access the legs member in the dog constructor. Now we can instantiate an object of type dog and access the inherited members as well as call its own bark method. So in our main method, static void main parentheses string args, in the curly braces for this main method we have dog d equals new dog, and then we have console.writeLine parentheses d.legs, and that's going to output 4. Then we have d with a dot operator and the bark method, which is going to output woof. A base class can have multiple derived classes. For example, a cat class can also inherit from animal. Inheritance allows the derived class to reuse the code in the base class without having to rewrite it, and the derived class can be customized by adding more members. In this manner, the derived class extends the functionality of the base class. Fill in the blanks to derive cat from animal. So we're going to create a class, so use the keyword class, cat, and the colon, and then animal, and then in the curly braces there's just a comment there that says some code. A derived class inherits all the members of the base class, including its methods. For example, class person, we've got a method inside that's called public void speak, and the instructions for the public void speak inside the curly braces is console.writeLine, and in parentheses and double quotes the string hi there. Okay, so then you close up the class person. Then you have class student person, and in the curly braces for this we have just int number. That's all that's in there that's new. And then you close up the class student person. And lastly, we're going to look at the main method, static void main string args, and in the curly braces of this main method we have student s equals new student. So we're creating an object of the student class, and we gave it a little short name of S. Then we use that little name, that object of the class, S, with a dot operator, and we actually call the speak method that's in the base class, and that outputs hi there. So we created a student object and called the speak method, which was declared in the base class person. C# does not support multiple inheritance, so you cannot inherit from multiple classes. However, you can use interfaces to implement multiple inheritance. You will learn more about interfaces in the coming lessons. How many base classes can one class have? Only one. Now let's look at protected members. Protected. Up to this point, we have worked exclusively with public and private access modifiers. Public members may be accessed from anywhere outside of the class, while access to private members is limited to their class. The protected access modifier is very similar to private, with one difference. It can be accessed in the derived classes. So a protected member is accessible only from derived classes. For example, class person, and inside the curly braces for class person, we have protected int age, and there's a get and a set inside the curly braces for age. Then there's protected string name, and there's also a get and a set in the curly braces for that string name. Next we have class student person, and in the curly braces for that we have public student, and in parentheses we have one parameter, string nm, and then in the curly braces for that public student we have name equal to nm. After that we have, still in the class student person, we have public void speak, so we have a method here, and in the curly braces we have an instruction for that method, console.write, parentheses the string name, and then we concatenate name after that. So then you close up your speak method, and then you close up your class student person, and then we take a look at the main method. Static void main, parentheses string args, and in the curly braces of this method we have student s equals new student, and then in parentheses we have the string David, which is an argument basically to the student constructor. It replaces string nm. And then the next line of code that we have in there is we're using the object of the student class, which is the lowercase s and a dot operator, to call the speak method that belongs to, it actually belongs to the student person, the student derived class. And that outputs the name David. Okay, as you can see, we can access and modify the name property of the base class from the derived class. But if we try to access it from outside code, we will get an error. So if we look at our static void main string args, if we look in our main method, in the parentheses we have student s equals new student, parentheses double quotes David. But if we were to try to run s.name equals Bob, we would get an error. Fill in the blanks to make the area method of the shape class accessible only in the derived class. So we're going to create a class called shape, and in the curly braces of the shape class we have public int h, and that has a get and a set in curly braces. We also have a public int w, which has its own get and set in curly braces. We want to make the area method accessible only in the derived class. So what keywords do we want to use? Let's go with protected. Protected is just for the derived classes. Protected int area is the method, and the instructions for the method are in the curly braces that follow. The instructions for the protected int area are return h times w. Then we close up the shape class. That's correct. Sealed. A class can prevent other classes from inheriting it or any of its members by using the sealed modifier. For example, sealed class animal, then in the meat of the curly braces there's a comment that just says some code. So outside of that sealed class, if we try to create a derived class, class dog : animal, with its curly braces, we'll end up getting an error. We cannot derive anything from animal because it has the keyword sealed. In this case, we cannot derive the dog class from the animal class because animal is sealed. The sealed keyword provides a level of protection to your class so that other classes cannot inherit from it. Fill in the blanks to derive a class B from class A and prevent class B from being inherited. Okay, we want to derive class B from class A, so let's create class A. All right, there's class A, and then some curly braces. We don't have anything in it, but we're just basically getting through to the syntax. What we want to do is we want to create our class B, and we want it to be a derived class of A. So in between B and A, we want to put our colon, because B colon A means it's a derived class of the base class A. Now, how do we keep class B from being inherited? Well, let's use that new keyword we just learned, sealed. Sealed class B colon A means we're creating class B to be a derived class of the base class A, but we don't want anything else to be able to inherit class B, so we're sealing it, and that's correct. All right, let's go to derived class constructor and destructor next. Constructors are called when objects of a class are created. With inheritance, the base class constructor and destructor are not inherited, so you should define constructors for the derived classes. However, the base class constructor and destructor are being invoked automatically when an object of the derived class is created or deleted. So consider the following example to understand this a bit better. We start off with our base class animal here, and in our base class animal we have inside a constructor, which is public animal, empty parentheses, and then in the meat of the curly braces for that constructor we have console.writeLine, the string animal created, just to show you with code what's running. And then we have a destructor, which is the tilde animal with an empty parentheses, and then in the double quotes for the destructor we have console.writeLine, the string animal deleted. Okay, so then you close up the destructor and you close up the class animal. So that's all the information that we have for class animal. Now let's create the derived class, class dog colon animal, and we're going to create a constructor and a destructor for this derived dog class. So just the same way that we created a constructor for animal, we do the same thing with dog. The keyword public and the name of the class, dog, empty parentheses, and then our curly braces, which has the instruction console.writeLine, the string dog created. Close that constructor up, and now we have a destructor for dog, which is the tilde with the name of the class and empty parentheses, and then inside the curly braces we have the instruction for that, which is console.writeLine, the string dog deleted. Close up the destructor and close up the derived class dog. Okay, so we have defined the animal class with a constructor and destructor, and a derived dog class with its own constructor and destructor. So what will happen when we create an object of the derived class? Tap next to find out. What is the maximum number of base classes a sealed class can have? Well, any class, whether it's sealed or not, can only have one base class, and sealed classes are no different, so it can only have one. That's correct. Okay, let's create a dog object. Remember, we create objects of classes in our main. So static void main string args. In our main method, in the curly braces, we have dog D equals new dog, empty parentheses, semicolon. The output from this is going to be the string animal created, and on the next line dog created, on the next line dog deleted, and on the fourth line animal deleted. Note that the base class constructor is called first, and the derived class constructor is called next. When the object is destroyed, the derived class destructor is invoked, and then the base class destructor is invoked. So you can think of it as the following. The derived class needs its base class in order to work, which is why the base class constructor is called first. What is the value of x after a B object is created? So here we have a base class called class A, and in the curly braces we have public int x equals 7, and then we have public A, which is the constructor, and in the curly braces for this constructor we have x plus plus. Alright, then we have a derived class B, which is class B colon A, and inside here we have public B empty parentheses, which is the constructor for this derived class, and the instruction for this public constructor in the curly braces is x plus plus also. Now, just like the previous example here, what happens is the base class's constructor is going to run first. Then the derived class's constructor is going to run. So, since in class A, the base class, we created public int x equals 7, x has the value of 7. And it's public, so it can be accessed from outside of a code block. Now, when the constructor public A empty parentheses runs, then x plus plus is going to change 7 to an 8. It's going to increment up by 1. Then when you get to the derived class B, that 8 is going to increment yet again. You've got x plus plus again, so that should give x the value of 9 at this point. So let's try that out and make sure that that's right, and it is. Alright, now let's move on to polymorphism. The word polymorphism means having many forms. Typically, polymorphism occurs when there is a hierarchy of classes and they are related through inheritance from a common base class. Polymorphism means that a call to a member method will cause a different implementation to be executed depending on the type of object that invokes the method. Simply put, polymorphism means that a single method can have a number of different implementations. Briefly, polymorphism is one method with different implementations. Correct. Consider having a program that allows users to draw different shapes. Each shape is drawn differently, and you do not know which shape the user will choose. Here, polymorphism can be leveraged to invoke the appropriate draw method of any derived class by overriding the same method in the base class. Such methods must be declared using the virtual keyword in the base class. For example, if we've got class shape, which is the base class, if we have public virtual void draw empty parentheses, then we're going to allow our derived classes to create their own draw method. But in the meat of the curly braces for this method, in the shape class, we have console.write the string base draw. Now the virtual keyword allows methods to be overridden in the derived classes. So it's public so that anything outside of the class can access it. It's virtual so derived classes can override it and do their own thing. And it's void because it's not returning anything, and the name of the method is draw. Virtual methods enable you to work with groups of related objects in a uniform way. So here we fill in the blanks to define a public and virtual method bark in the animal class. So in order to be the animal class, we have to use the keyword class, animal, and then in the curly braces, the instructions are saying that they want you to define a public and virtual method. So we're going to use the keyword public because we want to be able to access this from outside of this animal class. We want to use the keyword virtual because we want to allow the derived classes to make changes to the bark method. And so public virtual void bark, empty parentheses. In the meat of the curly braces for this method, we have console.write, parentheses and double quotes, the string barking. And that's correct. Now we can derive different shape classes that define their own draw methods using the override keyword. So let's create those derived classes. Class circle : shape. And in the curly braces for this derived class circle, we have public, override, void, draw, empty parentheses. Then in the curly braces, we've got the instruction on how to implement that draw method. In this case, we're going to have console.writeLine, parentheses and double quotes, the string circle draw. Close out of that method, close out of that derived class circle. Next we have another derived class, class rectangle : shape. And here we're going to call that same method with the public keyword, the override keyword, void and draw with an empty parentheses. And in the meat of the curly braces for this, we're going to give another different implementation of the draw method. So here we have console.writeLine, parentheses and double quotes, the string rect draw. Close up the draw method and close up the class rectangle. All right. The virtual draw method in the shape base class can be overridden in the derived classes. In this case, circle and rectangle have their own draw methods. Now we can create separate shape objects for each derived type and then call their draw methods. So in our main method, static void main string args, in the parentheses here, we use the base class name, which is shape. We give it a little short object name, in this case C, equals new, and we want to use the derived name circle, and then an empty parentheses and a semicolon. So shape C equals new circle. After that, we use that little object name C with a dot operator to simply call the draw method. So C.draw is going to output the string circle draw because it's specific to the derived class circle. The next thing we're going to do is shape. Again, we're using the base class name. Then we're going to give it a little object name R equals new rectangle. The rectangle is the derived class name. And we have an empty parentheses there and a semicolon. And just like the one above it, we're going to use the little object name of R, a dot operator, and it's going to call the draw method. So they're both calling .draw, but they both have their specific derived class implementations of draw. As you can see, each object invoked its own draw method thanks to polymorphism. Fill in the blanks to implement the bark method in the dog class. Okay, class dog, colon, wrong symbol. I put a semicolon on accident. Colon, animal. So we're creating a derived class. Dog is derived from animal. So class dog, colon, animal. We want to implement the bark method. So dog is going to overwrite not overwrite, override. Sorry about that. Public override, void, bark, You've got your empty parentheses there. And then in the curly braces, we have the instructions or the implementation for this specific bark. So public override void bark, empty parentheses, and the meat of the curly braces, the implementation, which is console.writeLine, the string woof. Check it and it's correct. To summarize, polymorphism is a way to call the same method for different objects and generate different results based on the object type. This behavior is achieved through virtual methods in the base class. To implement this, we create objects of the base type, but instantiate them as the derived type. And we did that when we said shape C equals new circle, empty parentheses and semicolon. So shape is the base class, circle is the derived class. So why use polymorphism? We could just instantiate each object of its type and call its method, as in circle C equals new circle and C.draw. Well, the answer to that is this. The polymorphic approach allows us to treat each object the same way. As all objects are of type shape, it is easier to maintain and work with them. You could, for example, have a list or an array of objects of that type and work with them dynamically without knowing the actual derived type of each object. Polymorphism can be useful in many cases. For example, we could create a game where we would have different player types, with each player having a separate behavior for the attack method. In this case, attack would be a virtual method of the base class player, and each derived class would override it. Class B inherits from Class A. The constructor of Class A displays the string A, while the Class B constructor displays the string B. So what is the output to the screen when the code capital A, lowercase a, equals new, capital B, empty parentheses is run? Well, based on what we've learned, when we have the code capital A, lowercase a, equals new, capital B, the capital A is the base class on the left-hand side. The new B on the right-hand side is the derived class. Remembering what we just learned, the derived class needs the base class in order to work, so the constructor from the base class is going to run first, which is going to output the little a. After that runs, the constructor of the derived B class is going to run, which is going to display the little b. So the only option that we have that shows both the A and the B output is this second one, AB. And that's correct. Okay, so we did derived class, constructor, and destructor. We did polymorphism. Let's look at abstract classes. As described in the previous example, polymorphism is used when you have different derived classes with the same method, which has different implementations in each class. This behavior is achieved through virtual methods that are overridden in the derived classes. In some situations, there is no meaningful need for the virtual method to have a separate definition in the base class. These methods are defined using the abstract keyword and specify that the derived classes must define that method on their own. You cannot create objects of a class containing an abstract method, which is why the class itself should be abstract. So we could use an abstract method in the shape class. To do that, we look at the following code. We use the abstract keyword, then the class keyword, and then the name of the class, which in this case is shape. And in the curly braces, we have public, so that it can be accessed outside of this class. We have abstract, which is going to require any derived classes to give its own instructions for this method. And then void, draw, empty parentheses, no curly braces, because we have no implementation, no directions for how to draw, just empty parentheses, and a semicolon to just stop that statement in its tracks. So as you can see, the draw method is abstract and thus has no body. You do not even need the curly brackets, just end the statement with a semicolon. The shape class itself must be declared abstract too, because it contains an abstract method. Abstract method declarations are only permitted in abstract classes. So if you're going to do anything abstract with a base class, make sure that you preface the class with the keyword abstract, and make sure when you name the particular method that you also use the abstract keyword. So you're going to see abstract class and then abstract whatever your method name is on the inside. Remember, abstract method declarations are only permitted in abstract classes. Members marked as abstract or included in an abstract class must be implemented by classes that derive from the abstract class. An abstract class can have multiple abstract members. Fill in the blanks to define an abstract method print for Class A. Now, this is telling you to define an abstract method for this class, so if you're going to have an abstract method, the class itself needs to be named abstract as well. So that's the first blank we're going to fill out, abstract. The abstract keyword, and I spelled it wrong. Abstract Class A. Then in the curly braces we have a method, a print method. We're going to use the public keyword. We're going to use the abstract keyword, void. The name of the method is print. We have empty parentheses, and we just finish that statement off with a semicolon. And that's correct. An abstract class is intended to be a base class of other classes. It acts like a template for its derived classes. Now, having the abstract class, we can derive the other classes and define their own draw methods. So again, we're going to go over the base class and two derived classes, and then we're going to see how that works and how we code it in the method, in the main method. So starting with the base class, we have abstract class shape, and in the curly braces for this, we have public, abstract, void, draw, empty parentheses, and semicolon. That's all we have for this particular class, this base class. Next, we have the derived class, class circle, colon, shape. We have to override the draw method, so we have the public keyword, the override keyword, and void draw, empty parentheses. Because this is overriding the base class, we have to implement it, which means we have curly braces that have instructions in what to do with this draw method. Console.writeLine, parentheses and double quotes, the string circle draw. All right, now let's move on to the other derived class, class rectangle, colon, shape. Again, public, override, void, draw, empty parentheses. We got to put an implementation inside for the draw method. So in the curly braces, we have console.writeLine, parentheses and double quotes, the string rect draw. Moving on to the main method, we're going to create objects of those derived classes, or at least one. So static void main string args. Inside of this, we have shape, which is the name of the base class, C, which is a little shorty name for an object of a class, equals new circle, empty parentheses, and semicolon. Now we're going to use that little object name, C, a dot operator, and just draw. We're calling the draw method with our empty parentheses and our semicolon. That's going to output circle draw. Abstract classes have the following features. An abstract class cannot be instantiated. An abstract class may contain abstract methods and accessors. A non-abstract class derived from an abstract class must include actual implementations of all inherited abstract methods and accessors. It is not possible to modify an abstract class with the sealed modifier because the two modifiers have opposite meanings. The sealed modifier prevents a class from being inherited, and the abstract modifier requires a class to be inherited. Fill in the blanks to create an abstract class with an abstract method and then use it as a base class. Okay. We're going to create an abstract class with an abstract method. Abstract class animal is how we get it started. And inside we have public abstract, I spelled it wrong, public abstract void eat, empty parentheses and semicolon, so there's no implementation for that method. Then we have the derived class dog colon animal. We are going to create our own, the dog's implementation of eat. So public override void eat, and then the implementation is in the next curly braces, which is console.writeLine, in parentheses and double quotes, the string Check it, and that's correct. Okay, now we're moving on from abstract classes to interfaces. An interface is a completely abstract class which contains only abstract members. It is declared using the interface keyword. So here we have public, the keyword public, the keyword interface, the capital letter I tacked on to shape. Inside the curly braces, all we have is the keyword void, the name of the method draw, empty parentheses and semicolon. So it's really short. All members of the interface are by default abstract, so that you don't need to use the abstract keyword. Also, all members of an interface are always public, and so no access modifiers can be applied to them. So this is really shortening up our code. It is common to use the capital letter I as the starting letter for an interface name. Interfaces can contain properties, methods, etc., but cannot contain fields, which are variables. Is the following interface valid? Public interface iTest, and inside the curly braces we have int test and void func. Well, we just read where interfaces cannot have fields, which are variables. So int test would make this an invalid interface. So we have to say no, that is not a valid interface. And that's correct. When a class implements an interface, it must also implement or define all of its methods. The term implementing an interface is used, opposed to the term inheriting from, to describe the process of creating a class based on an interface. The interface simply describes what a class should do. The class implementing the interface must define how to accomplish the behaviors. The syntax to implement an interface is the same as that to derive a class. So let's see, we've got our base class here, which is now called an interface, and then we have a derived class of that interface, and then we have our main method in which we create objects of the derived class, and then we call a method from the object. So starting at the top, we have public, the keyword interface, the capital letter I right in front of the name of the base class, so we have public interface iShape. And then in the curly braces for this interface, we just have the keyword void and the name of a method with empty parentheses, no curly braces at all, no implementation, no directions for how to do the draw, and just simply a semicolon. Now we're going to create a derived class of this interface. We are going to implement the interface. So we're going to implement the interface with class circle : iShape. We are going to use the keyword public and then void draw, just like the interface, but this time after the empty parentheses we do have an implementation which is in curly braces. The implementation is the direction, the instruction, console.writeLine, parentheses, double quotes, the string circle draw. Okay, so then we close up the implementation of that draw method, and then we close up the derived class circle, or the implementation of the interface, if you will. And then we're going to look at the main method and see what we do there. So we have static void main string args, as we always do. And then inside there we have, just like we did when we were just dealing with the base class and the derived class, we are calling the name of the interface, which is iShape. Then we're creating a little object of the derived class, some little shorty name, in this case C, the letter C, equals new circle, because we're creating C as a new circle. The next line is using that little C with a dot operator to call draw. So C dot draw, empty parentheses, and semicolon. And what that's going to do is it's going to output the string circle draw. Note that the override keyword is not needed when you implement an interface. So here it's called implementing an interface, whereas before it was called creating a derived class. So we don't need to use the word override. The question now is, why use interfaces rather than abstract classes? Well, the answer they're giving is that a class can inherit from just one base class, but it can implement multiple interfaces. Therefore, by using interfaces, you can include behavior from multiple sources in a class. To implement multiple interfaces, use a comma-separated list of interfaces when creating a class. So this is pretty cool. Here they're saying class A, iShape, iAnimal, on and on and on. So this is allowing a class to get methods and behaviors from more than one source, more than one interface. All right, fill in the blanks to create an interface and implement it. So we have to use our keyword. Somehow I don't think that's right. Let me back up. I'm getting my keywords mixed up. Public interface iShape. I'm going to use the keyword interface, the name iAnimal. Inside the curly braces, I have very simple statement, void eat, empty parentheses, and semicolon. Now I want to implement it, and I forgot the keyword for the implementation. Class. Should just be class, I suppose. Uh-oh, I lost my spot. Let's go back to this again. Interface, keyword, iAnimal, void eat, then class, dog, iAnimal, public void eat, And the implementation of that is in the curly braces, console.writeLine, parentheses, double quotes, the string, And we're correct. After interfaces, we have nested classes. C# supports nested classes, which is a class that is a member of another class. For example, class car. Inside of class car, we have string name. Then we have public car, parentheses, string NM. And inside of public car, we have name equals NM. And motor M equals new motor, empty parentheses, semicolon. All of that is in class car. Outside of that, wait a minute, let me see. String name is in car, public car with a parameter of string NM is in car, and public class motor is also inside of class car, but it doesn't have any other code. It just has a comment there that says some code before we close up the whole class. So what this is saying is that the motor class is nested in the car class and can be used similar to other members of the class. A nested class acts as a member of the class, so it can have the same access modifiers as other members, which are public, private, or protected. Just as in real life, objects can contain other objects. For example, a car, which has its own attributes, the color, the brand, and so on and so forth, contains a motor, which has a separate object, has its own attributes, volume, horsepower, and on and on. So here the car class can have a nested motor class as one of its members. Rearrange the code to have a nested class hand, which has a method called shake that prints hi. Alright, so we're going to start off with our class person. Inside of person, we have class hand, and inside of class hand, we have a method called public void shake, and inside the curly braces of public void shake is our implementation or directions, which are console.writeLine, parentheses, double quotes, the string hi. The last thing is the closing of the curly brace for class hand, and the closing, the closing of the class hand, and the last one is the closing of class person. And that's correct. Okay, now we're on to namespaces. When you create a blank C# project, it has the following structure. We've got 5 using statements here. Using system, using system.collections.generic, using system.link, using system.text, using system.threading.tasks. Then you see namespace, solo learn, and an opening parenthesis. Then you see class program and an opening parenthesis. Then you see static void main string args, and then its own set of curly braces. I said opening parenthesis. I meant opening curly brace. That was my mistake. So you have all of these curly braces for namespace, for class program, and for the main method when you first open your C#. So note that our whole program is inside a namespace. So what are namespaces? Well, namespaces declare a scope that contains a set of related objects. You can use a namespace to organize code elements. You can define your own namespaces and use them in your program. The using keyword states that the program is using a given namespace. For example, we are using the system namespace in our programs, which is where the class console is defined. So you have using system, semicolon, then whatever other using statements, console.writeLine, parentheses, double quotes, the string hi. Well, without the using statement, the using system that we have at the top of the page, we would have to specify the namespace wherever it is used. So instead of just typing console.writeLine, parentheses, double quotes, the string hi, we would have to write system.console.writeLine, parentheses, double quotes, hi. The .NET framework uses namespaces to organize its many classes. System is one example of a .NET framework namespace. Declaring your own namespaces can help you group your class and method names in a larger programming project. Rearrange the code to create a generic C# project code structure. All right, it actually looks like it's already in order. You start off with using system, then you have, namespace is next. Then you have namespace, solo learn, then you have class program, then you have nested inside of all of those static void main string args. This is the main method that starts the ball rolling in the program. Then you close up all of the curly braces, the curly brace for the main method, the curly brace for the class program, and the curly brace for the namespace, solo learn. And that's correct. Okay, that brings us down to the Module 7 quiz. Can you instantiate objects of an abstract class? No, you can't. Fill in the blanks to define a new class falcon, which is derived from the class bird. So you start off with the class keyword, falcon, a colon, and then bird. Which keyword makes class members accessible to only its derived class members? Makes class members accessible only to its derived. I want to think that that's the protected keyword if I'm remembering correct, and I am. Fill in the blanks to declare a person class with a hello abstract method, and then declare a student class that is derived from the person class and overrides its hello method. Okay, well, to start off, if we need to create an abstract method in a class, that class has to be abstract as well. So our opening keyword is going to be the word abstract. Abstract class person. Inside we have public abstract void hello. Now we're going to derive student, class student. We got that same colon person, public override. We need to override. Public override void hello. And then we have the student's implementation of the hello method, which is in our curly braces, console.write, parentheses, double quotes, the string hello. And that's correct. A sealed class can be marked as abstract. No, it can't. A sealed class means that nothing can inherit from it, whereas an abstract class means that the derived classes must make their own implementation of it. So no, it can't be sealed and abstract at the same time, so that's false. And that's correct. Fill in the blanks to implement the A and B interfaces. Okay, so we have interface A and interface B, class test I'm getting my keywords confused. Okay. Oh, now I remember. You can implement A and B interfaces, class test, A, comma, B. That way we are implementing both the A and B interfaces. That should be right. Class test, A, comma, B. And I'm correct. All right, next, can a single class inherit from multiple abstract classes? Can a single class inherit from multiple abstract classes? No, that's the reason we have to have interfaces. And that's correct. All right, and that finishes inheritance and polymorphism. Next time we'll go over structs, enums, exceptions, and files.